Okay, good day, Mr. Irham. Welcome to our presentation. We are from Group 2 about the line follower robot. To start off, we are going to introduce ourselves. Our group consists of Ovtapia, Kevin, Gabriel, Ginting, and then myself, Muhammad Raykhul. Now, to move on to the next section is the general introduction of the line follower robot. It is a robot, an autonomous mobile robot designed to detect and follow a visible line, usually a black line on a white surface, to make it a contrasting track, and it is widely used in education, industry, and competitions for tasks like material transport as well as automation. The working mechanism between a for this robot involves sensors mounted at the front of the robot to detect the line's position. These sensors send signals to a microcontroller. As you can see from the picture, it uses an Arduino for the time being, which processes the data and commands the motors to adjust the robot's direction, making sure that it stays on its path. Next is the general function of the line follower robot. From the picture on the right, you can see that it is pulling some kind of load in a factory, and it is designed to autonomously navigate by detecting and following a specific path. As I said before, the black line on a white surface and usually a visible line on a surface, like I said before. Using sensor for continuous course correction. These robots are commonly used in indoor classrooms, labs, and arenas with flat surfaces and minimal lighting interference due to it. I think using the infrared, if I'm not mistaken, as well as in industrial setting like factories and hospitals where permanent tracks and durability are essential. It is also adaptable for semi-outdoor and special environments. Line follow robots can handle natural lighting, rougher surfaces, or complex paths with obstacles, making them suitable for experiments and advanced project. But for the time being, I think mostly used in very, very flat surfaces like factories and hospitals. And to continue on, the practical usage of this robot is first from the left is to move objects, heavy object like boxes or anything alike using AGVs, automatic guided vehicles. This is the one from Amazon Robotics, moving packages and whatnot. And on the middle, hospital delivery robots like the TUG autonomously transport medications, meals, or linens by following map paths or lines in hospital corridors. And the last example is the food delivery robots, I think present in restaurants. Examples like Kinon and the Pudu bot autonomously deliver meals from kitchens to restaurant tables by following a designated path using floor sensors, improving its efficiency. And next is the brief history of the line follow robot. In the 1950s, there is a line follow robot concept emerges from early reactive robotic research. In 1962, a robot named Emily, early white line follow robot, demonstrate basic line tracking. In the 80s, microcontrollers are implemented because it is affordable complex line follow robots, accelerating its development. In the early 2000s, popularity in this usage of robot grows in education and competitions for teaching robotics fundamentals. And in the present time, line for robot technology is widely applied in industrial settings like factories, hospitals, and evolving with advanced sensors and control systems. Now, moving on to the next, will be carried by Rachel.
Okay, so now is about the control system. So a line follower robot uses an autonomous control system, meaning it can move and make decisions on its own without human help. It follows a path by reading sensor data and adjusting its movement automatically. This robot mainly uses low-level control. It directly reads sensor input and control the motor, making quick adjustment to stay on the line. There is a little complex thinking or planning involved. The line follower robot uses bang bang or on off feedback control by switching motor speeds abruptly based on sensor threshold. This simple method steers the robot left or right, resulting zigzag motion, and is easy to implement but less smooth and precise than advanced controls. Next is the drive system. So most line follower robots use a wheeled locomotion, typically with two motor driven wheels and caster wheel for balance. This simple, cost-effective design works well on flat surfaces like floor or tables, making it ideal for basic line following tasks. Other locomotion types are rare due complexity. The transmission mechanism in line follower robots is usually direct, with motors connected straight to wheel via shaft or gearboxes. This direct drive enables quick response and easy control, perfect for beginners. Occasionally, simple gear reduction is applied for torque, but it's remain part of the direct drive system. Steering release on the differential control, adjusting each wheel speed and direction ident, ident,
Independent.
independently,
Yeah,
equal
independently.
speeds must move the robot straight, while varying speeds causes turns. These straightforward methods allow precise navigation on flat surface. More complex steering types like omnidirectional wheels are uncommon in basic line followers.
Okay, next up is the robot simulation. I will go into it real quick. Here, if I run the simulation, you can see the robot is slowly following the line to the side. And as this is running in the background, Gabriel will try to explain the line tracer code. Gabriel, if you may.
Okay, yes, thank you, Ray. So this Coppelia code controls a simple line follower robot. It starts by initializing the robot's left and right wheels, or joints, and the sensor in the cycles init function. The sensor detects the line's color intensity beneath them. In the syscall sensing function, the robot reads data from the left and right sensor, specifically the average intensity values, which indicates how much the sensor sees the line. The syscall actuation function uses the sensor data to detect the robot's movement. If the right sensor detects the line strongly but the left does not, the robot turns right by speeding up the right wheel. If the sensor detects the line but the right does not, it turns left. Otherwise, both wheels move forward at a constant speed. This simple feedback loop helps the robot follow a line by adjusting its direction based on a sensor input.
Okay, thank you. Now we can go back into the presentation for the analysis and reflection. Kali, if you may again.
Yes, and for the analysis and reflection, the challenge in this project lies in the designing the simulation to set the right settings for the robot's program. It's important to adjust the sensor and how fast the robot reacts. Also, making a good track for the robot to follow is needed to test how well it works. This type of robot has several pros and cons, such as being easy to build and not expensive. They are good for learning how robots works, but they can only follow a line and cannot do many other tasks like more advanced robots. This limits their use in real life. An improvement to this type of robot can be done by adding features like avoiding obstacles or sending information wirelessly. It can also learn to follow different paths. This change can make the robot smarter and able to do more things on its own.
Okay, thank you everyone. And I think that is all from our presentation. Thank you, Mr. Irham,